Okay, we're live. So, I guess we'll just kind of dive into part two, unless anybody has any questions.
Um, I looked over part two a little bit. I didn't do any of the actual math or anything. But I understood part one really well. It totally made sense. But it seems like part two doesn't really have anything to do with part one, and so I just
Okay,
kind of confusing for me. So I'll do my
we
best.
uh, we can go over it and see what's going on.
Okay.
Okay, we'll
Okay,
start with
just a
one.
second.
Let me know when you're ready.
Well, I just realized that I got out of my stuff. Okay.
Okay, so it says, suppose pair computing sold an average mean of 45 P phones per minute in 2011. Yes, that means they sold 23 million P phones in 2011 with a standard deviation of 10, and they looked at their phone sale data and determined that they are normally distributed. Okay, so question 4. Sample size N4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of the group of means? Should be normal.
Right.
So so for number 5, it says that the sample is 40, and so I understand why that would be normal because it's a pretty big sample. But why is number 4 normal since it seems like the sample size is pretty small?
So there's two things that cause a statistics group to be normal. The first is if the data is already normally distributed, it will always be normal. And the second is if n is greater than 30. And so in number 4, it says that the data is already normally distributed.
Because it says
So we
taken
don't
from
really have to worry about it.
Yeah, so it's going to be normal no matter what the sample size. If it's 2, 1, whatever it is.
because it says it's from the normally distributed 2009
Yeah.
sales.
Right, but per se, like if it was right skewed data and then their sample size was 4, then we would expect the distribution would be right skewed because it's not a big enough sample size to make it normal. If that makes sense.
Okay, that makes sense.
Okay, so 5 is normal as well, like we talked about. Okay, 6. A sample size of N4 is taken from the normally distributed sales. What is the probability that the observed mean will be greater than 40?
Less than 40.
So we just use that that formula, right?
Right.
So we go 40 minus 45 over the standard deviation times the square root of the...
So do we let's see. Yeah, by the standard deviation.
So 10 on the bottom of the fraction, 10 times the square root of 40. What is it?
That's what I'm trying to figure out because we do have an n size, so I'm not sure if it is. Let me calculate it real quick.
So the n, we square root the n, right? So it was square root of 4.
But it's 10 divided by the square root.
Right. So square root of 4 is 2, and then 10 divided by 2 is 5.
5, right? And so it should be 5 over 5.
Yeah, negative 5 over 5, so it's negative 1.
Negative 1. So then we put that into the probability applet.
Right.
And we put greater than, so the right side is highlighted. So the probability would be 0.159.
Okay, yeah.
Everybody else get that?
Yeah.
Okay. A sample size of 4 is taken from the normally distributed sales data. What is the probability that the observed mean is greater than 35 and less than 50? So we have to put those together.
Right.
We have to get the z-scores separately.
So we don't have to do the bottom number over again because it's the same. Because it's still, the inside still is 4. Right?
Other than now the numbers are 35 and 55.
Right. But the bottom number we don't have to change.
No, that's
5
2.
minus 45 divided by 5.
Yeah, so that'd be 5.
Right?
Yep.
So there's 2 and a negative 2 I got. So,
Yeah, 2 and negative 2.
and so
let me
you
put
just
that-
put those numbers.
So it's greater than 35, so the right side of negative 2 should be
Greater than 35, and that's negative 2. And
right.
less than 55.
Is greater than 35 the middle part too?
Yeah, it must be the middle part. Just only the middle part. Is that right? Because if it's greater than negative 2 and less than 2, it's got to be the middle part.
Yeah, it would be only the middle. Yeah, that makes sense.
Yeah. Where I'm not hearing Mackenzie again.
I can't hear her either. She's freezing up. That sounds bad. So,
Okay,
so it would be, what did you get for that?
Did you do number 8 already? Oh.
No, 7.
7.9545?
Yeah, okay, that's what I got too.
0.955?
Yep.
Yeah.
So then, okay, so now we have greater than 41 and less than 49.
There was square root of 25.
Wait, so that's the-
Two on the bottom. 41 minus 44 equals negative 2. Negative 2. So I got negative 2 on the 41, I guess.
Yeah, that's what I got too. Negative 2.
49 minus 45 is 4.
Positive 2.
And positive 2. So then,
Same thing.
so what is it asking? What is the probability that is greater than 41, so greater than negative 2,
And less than
and less
2.
than 2? So it's the same exact number?
Yeah, same exact number.
So 0.955.
Okay. I don't know if we're going to get Mackenzie back or not. Looks like
You
she's
see her
dropped
now?
out of the call. Yeah, she's dropped out of it completely.
That's frustrating. Dang
Yeah.
it. God. I wish she could go somewhere she could get better internet.
It sounds like.
Oh,
Are
here
you
she
back?
is.
Oh, there you are.
Hey.
Sorry. Okay, so are you guys on number 8?
Yeah.
Yeah.
Okay.
So we got negative 2 and 2 is the z-score.
Again?
Uh-huh.
Again. So it's the same
That would've-
probability.
Okay.
So, okay, number 9. A sample size n is taken from the normally distributed sales data. What is the probability that the observed is greater than 50? So 50 minus 45 divided by 10 divided by 25 or 2.
Wait, so why are you doing why do you say 10 divided by the square root? Because isn't it times?
It's divided by.
It is?
Yeah, the formula is divided by.
This is a new formula. The other
Yeah, this
one,
one's a new one.
Yeah. The other one was times, but this one's a new one.
Oh, okay.
This is for the sample mean.
Yeah. I was just looking at it wrong this entire time. I did not see the divided sign like all this time.
Yeah.
I get it.
Okay. So then we put. I got 2.5.
Yep.
It's going to be greater than.
Okay, so we just put 2.5, and then it's greater than, so it's a really little number.
Yeah, because it's going to be the top.
So it's 0062.
Yeah. That's what I got. Okay.
The hardest thing for me is trying to figure out what I'm supposed.
Yeah, what are you supposed to? Yeah, I don't get that either.
Okay.
Wait, is that what you said?
Yeah.
Yeah.
Knowing that you're not supposed to shade the middle, but you're supposed to shade above the middle, and some cases you're not supposed to shade. I don't know. Okay. Pear Company Computing sold an average of 40 P-phones, standard deviation of 12, 10. Sample sizes and are taken from a right-skewed P-phone sale. What is the shape of distribution? So that's right-skewed.
Right-skewed. What is that? Okay.
The sample size is 40. What is the shape? That's normal. Is there a theorem that justifies your answer in 11? What is the theorem? That is the central limit.
Limit theory.
Do we have McKinsey still? Did we lose her again?
Yeah.
Okay.
Okay. Just making sure you're there. Okay. A sample size of N4 is taken from the right-skewed data, and you want to know the probability the observed mean will be greater than 35. Can you compute this probability using normal probability output with the information you have? Why? You cannot, because it's right-skewed.
So would you just use a box thing for that, or how do you do that? Do you know?
I don't think you can.
We'll learn. Okay.
Yeah, you just can't do it.
Okay.
A sample size of N36, though, is taken from a right-skewed. What is the probability that the observed mean will be greater than 3? We can do that one.
Right. 36.5. So our mean, where are we at? Our mean is
40.
So minus 40 over the sample.
12, and the sample size is 36.
12 and the square 36. So
okay, I got negative 1.75.
Yep, I did too.
Okay, so it's going to be greater than 36, so I would assume we're highlighting just the top part, but I don't have a clue. Because it's a negative, so maybe you have to highlight the middle too?
1.75. So let's see. So it's asking greater than, and the score is a negative, so greater than the negative would be everything above that.
Right, that's what I would assume, and that's what the answer is, I believe.
So it's 0.9599?
Yeah. That's what the answer is on the little...
It's not 1 minus that?
It is not.
Oh, okay.
That would be the opposite of it. That would be less than.
Okay.
9.
Okay.
Okay, how come the thing that says 9545 and ours says 959?
Which thing?
The answer I'm looking on the wrong answer. That's why. I'm looking at the wrong answer. Okay, never mind.
0.9599. So
Yeah,
I think we
that's
got
right.
that. Okay, so a sample size of N36 is taken from a right skew 2010 sales. What's the probability that the observed mean will be between 37.5 and 42.5? So same thing.
5 minus 40 over. And it's 36, so we can use that same bottom number.
Yep, which is 2.
2.5 minus 40 divided by 2.
Negative 1.25.
Yep. Negative 0.25. And and 1.25.
Yep.
Okay, so it's asking what is the probability that it's between.
So the middle.
Suggestion of the middle. 0.7887.
Yeah.
Yep, that's what the answer is.
Okay. Cool. We will start the quiz then.
Okay, wait. I didn't do that right.
Okay.
It's because I have 127.12. Negative 1.25. Okay, I got it.
Okay, so I'll start the quiz then. Okay, everybody in the quiz now?
True. Yes.
Okay, so using the normal probability applet to find the combined area under the standard normal curve that is to the right of 1.358 and to the left of negative 1.358. So that would just be put that number in, right, and then just the area shaded to the right and to the left.
So the middle part.
I don't think it's the middle. I think it's to the left and to the right.
To the right. Okay, on either side then, is what they're saying.
Yeah.
So 0.1745?
What was it? 1.358? Is that what it is?
Yeah.
Yeah, 0.1745. So 0.175?
Yeah.
Okay.
Okay, the United States Coast Guard assumes that the mean weight of a passenger is 185 pounds. The previous value was lower but was raised after a tragic boating incident. The standard deviation for passengers' weight is 26.7 pounds. The weight of a random sample of 48 commercial passenger boats were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that the random sample of passengers will have a weight that is as extreme or more extreme, so either above or below the mean, than was observed in the sample.
Okay, what?
As extreme or more extreme means that we are not only interested in the values that are lower than the ones we observed, but also that are as far away from the mean as are in the positive direction. Oh, what the heck? Okay, so I guess let's just get what we know written down.
Okay, mean weight is 185.
So why is the sample mean 177.6?
The previous value was lower but raised and the standard deviation is 26.7. Sample of 48, so we have random sample of 48 we recorded. The mean sample was 177.6. So that's different from the
Yeah, that shouldn't be different,
mean weight. The previous value was lower but raised. The mean sample was 177.6. Find the probability of the random sample. So I guess 185. What does that mean? Oh, that's what they normally see. That a little bit. That's the standard. That's what they assume the standard is.
Okay, yeah.
Oh, that's not the actual mean.
So mean is the 177.6.
Yeah,
so
I think
how
so.
do you remember that now? Like when they were doing that thing about anyway, it gave what the standard for like the amount of radiation or something in that one problem.
Yeah, I remember that.
Is this like that kind of maybe?
Perhaps. Let me.
Okay. Find the probability that a random sample patient will have a weight as extreme or more extreme,
either above or below the mean that we observed in this sample. So the sample.
So we're using the 177.6.
Yes. I don't think the 185 means nothing to us.
That's just to throw us off.
Yeah.
Okay, so 177.6 is the mean. And so, oh, no, it is. The 185 is the first number.
Yeah. We use those as a subtraction
minus
in the top.
the 176, right?
So it's 185 minus 176.
Over the standard deviation, which is 26.7 over the square root of 48.
Divided by, yeah, so 48. Yeah, I think that's right. That seems right.
All right. Okay, so.
Yeah.
Okay. 26.7. It's 26.7, right?
Yeah.
Divided by 6.928 equals.
Not 192.
Okay, so the bottom is 3.854.
I got 1.92.
77.6 equals divided by 3.8.
Then we put that in the applet.
I got 1.92. Is that what you got?
Yeah, 1.920.
Yeah.
Okay.
And so what are we trying to answer then here? So that's the z-score.
Yes.
Yeah.
So as extreme or more extreme means that we're not only interested in the values that are lower than the ones we observed, but also the values that are as far away from the mean as ours in the positive direction.
So in our z-score is positive, right? It's 1.920 positive.
So do we put that in the applet and then shade the left and right sides?
Kind of think that's what we do. So we're trying to find the probability have a weight as extreme or above or below the mean.
Yeah.
Is observed this sample.
Yeah, so I think you'd shade both sides.
Like
but I
shade
don't know.
everything in the middle?
If you shade everything, you're going to get 1.
Well, I just don't know if you shade the opposite sides or if you only shade above.
Yeah.
Because the mean is 1.90. Random sample of a weight. Extreme or more extreme. Either above or below the mean was observed. Probability that the random sample will have a weight as extreme or more extreme than the mean of 1.9. I don't know. What do you think?
I don't know either. I want to say that you would shade both, but it doesn't make sense that you would shade the opposite sides because you're completely leaving out that data that's the mean. So I think it's from the negative up.
So the z-score is positive for this though.
Yes, that's true.
So our z-score is that positive line,
Right.
not the negative.
And the z-score
above the z-score because we want to know as extreme or more extreme. But why does it say either above or below the mean? What does that mean? So it seems like you would just shade the top part, but is that wrong?
I'm not sure.
What do you think, Mackenzie? Do we still have her?
Let me see. I'm going to go look at our reading again real quick. Okay, so
Have a weight as extreme as the 185.
So
Can you guys hear me?
Yeah, we can hear you.
Hello.
Hello?
Hello?
The middle. Hello.
Hello?
So the z-score is the area standard, right? Like that's like the mean. So above it.
You can hear me? Yes. No.
Yes, I can. Can you hear us? No.
That's confusing. Above and below the mean.
Okay, well, the mean would be 177.6. So, do we have to do two? Do we have to do two calculations?
I don't know how we could.
Yeah, so
because we don't have two different weights.
Numbers. Yeah, so
above the mean and below the mean. So it's for sure above it.
Right. But below the mean would be, because we're trying to find out the random will have a weight that is as extreme. But why does it say above or below?
I want to say that we shade the middle. Because...
Really?
But I don't know. I guess we can all try something different. Maybe we'll just skip that one for now. Come back to it.
All right, let's come back to that. Let's think about it. Okay. Because I just don't know. Which of the following will have is she here?
I don't think so.
No? Okay.
Okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of an individual observation? Oh. We'll have a smaller standard deviation.
9 observations are randomly drawn from a population. That doesn't give us enough information.
No, because you need to know the size, sample size.
Right.
To determine whose sample.
Yeah, because we just can't know from the 9 observations.
From the mean, yeah.
Can't know that.
Okay, so which of the following implies that the spread of the sample mean decreases as the sample size increases?
Large central theorem. What is that one? The spread. Oh, isn't that the law of large? Isn't that the central limit theory?
The spread in X decreases as the sample size. Yeah, I think it is a central limit theory.
I do too. Let me look and see. I think I have it.
But they're phrasing these like way bad. Like what? Why is there a purpose in phrasing them like that?
Okay, I'm reading this. It says the central limit theory states that if the sample size is large, the sample mean will be approximately normally distributed. The law of large numbers states that the sample stop doing that. And the law of large numbers states that the sample size increases, the standard deviation of the sample mean will get smaller. Which the following implies that the spread will decrease as the sample size increases.
So would that be the law of large numbers?
Spread increases as the sample decreases.
It's got to be. It's either what does the spread determine? How close your standard deviation is to your mean?
Right. The spread, the larger the spread, the bigger the standard deviation.
Yeah, so it would be the law of large numbers. So the spread gets lower as you increase sample size. Yeah, law of large numbers. Okay. Scores on the...
guys? Can you hear me?
Yeah, we can hear you.
Finally.
Scores on
we
the...
skipped number 4, Mackenzie, because we didn't know what to put yet.
All right. Sounds
We'll
good.
come back.
Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150 and a standard deviation of 8.8. Use this answer. Okay. Diana earned a score of 160 on the quantitative portion. What is the z-score corresponding to Diana's score? Okay. So that's...
So Diane's would be like the standard.
Hers is, so it'd be 160 minus 150.8.
Yeah.
Divided by 8.8, right? Because we don't have a sample size here.
No. So her z-score would be 1.045.
60 minus 150. I got 1.045.
Yeah. Okay, so what is the z-score? Okay, so
1.04.
1.045.
Yeah. Okay, so what is the probability that a randomly selected student will be above 160?
Okay, how many numbers did you write? 1.0454?
No, 3.
Three of them. Okay.
I think so. Yeah, it says if your answer is 0.
Okay, sorry. All right.
Okay, so then we need to put 1.045 and shade above that to get our next one. Okay, so I got 0.148.
Yep.
Okay, just a second. 1.045. 1.148. Is that what you got?
Yeah. At a random sample of 5 students were taken, their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores?
So we need the mean. We need to figure that out.
So the z-score is the sample mean. So we need to get a sample mean. So we add all those together?
Yeah. But see, this is confusing because I thought the sample mean was always the same as the mean.
But we don't have a mean at all on this one, so we have to find the mean. Right? Because have they given us a mean?
Oh, let's see. 7 through 10, yeah, because our normal mean. Yeah, so that's what I don't get, but I think we have to still do this, because how are we going to take a random score that wouldn't give us the same?
So it's saying a random sample, the scores are that. So it should equal the same.
Yeah, it says 160. So it should be 160 minus 158, and then it should be 8.8, but we have a sample size now, 5 students.
So the same thing except we divide 8.8 on the bottom divided by the square root of...
Yeah, 5.
60 minus... Okay, how come I'm really, really lost? 5.8 is the mean. So where did we get 160 from? Is that what the...
That's the mean of all those 5 numbers.
Okay, so you already had those. 160 minus 150.8.
Okay, I got 2.338.
So I got 2.
Okay, me too.
Okay.
The sample size is 5.
That's what we put in for 9, 2.338.
Yeah.
Okay.
10. What is the probability that the 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Not. Oh, so the mean score. So we find that by
you have to use the applet, wouldn't you? Because the applet tells us probability.
right.
So what is the probability that the 5 students will have a mean score that is greater than the mean achieved in the previous problem? Man, the wording in these are garbage sometimes.
So the mean in the previous problem is the 160?
I guess so, yeah.
Yeah, we put in
2.338.
And then shade just the top part.
Yeah. Right.
0.097.
Yeah, 0.09. So, how do you round that up? Is it 0.01?
0.001.
0.010, I think what it is.
0.001.
Just 010. Because you have to round up the other number because of the 9. Because the 9 turns into a 1.
So 0.0010?
No, 0.01.
Oh. 0.01.
Okay, but here's what I don't... This is where I'm getting confused because we haven't done any problems like this. So, you know, when we took the sample score on number 9, the sample mean there, what is that number?
Okay.
Is that the sample mean?
Plus.
Because if that is the sample mean, then we're doing this wrong. Because then we would need to subtract from that number, if that makes sense.
Right.
160. Okay, what are you saying?
It would be 150.8 minus 160 for this problem?
Well, if that is the sample mean, but like remember on our question up here that we were doing, number 4, the way that we did it was the sample mean. We determined the sample mean, which was 177, but we subtracted 185 from 177, so we subtracted the mean from the sample mean, which is where this is where I'm getting lost.
Okay.
Because we're doing it either right or we're doing it wrong.
Okay. Let's see.
Because if that's the sample mean, we're either doing opposite.
Okay, so the value that we get is the number that needs to go first, and then we subtract the mean that it gives us.
Okay.
So for number 10, let's see, or 9, I guess.
Score.
We take 160 and then minus 8. We did number 9, right?
Right.
So then for number 4, it would be 177.6 minus 185. So we negative number on.
It would be backwards than what we had.
I don't know. That's what I don't get.
185 minus 177.6. It would be the other way around.
Well, if it is the sample mean that we're finding, because in our equation, I don't know. That's where I'm getting confused. I need to go look at the book again.
Oh, it says, yeah, the formula says the sample mean minus the mean.
Is that what it is?
Yeah, the x was the thing over the top minus the u. So that's the sample mean minus the mean, right?
Yeah, x with a thing over it, is that sample mean?
Yeah, so it would be 177.6 minus 185.
Okay, so we're doing it right. That helps to know.
Actually, I was doing it wrong. 177.6 minus 185.
So what did you do?
I did 185 minus 177.6.
Isn't that what isn't that right?
No,
I thought it was the other way.
I think it's the opposite.
Because 185 is the mean that they give us.
So it's 177.6 minus 85.
Oh, on number 4.
The number.
Only on number 4 we did it wrong.
Yeah.
Right.
Okay.
So number 4, we get a negative number on top.
Right, and then the bottom number, yes, and then the bottom number is square root of 40.
So that changes things on that one.
Yeah, but then we still were kind of confused about what to shade.
Right, but if we're shading above it and below it, that's going to be tricky. So
I think maybe what we do is we have to get 2 values, and so like we shade to get the upper extreme. To find that out, we shade, find what that is, and then to get the lower extreme, we find the middle part. We shade the middle part and the upper part, and then we find the value of the lower part, and then we add those 2 together. Does that make sense?
yeah, that does, but that should equal 1, if that makes sense.
Oh yeah, that would. You're right.
So maybe that's the answer.
So we still have 1920, right? As the z-score? I mean, 1.920.
For number 4?
But it's negative?
Yeah.
Oh.
Is that right?
Let me do it real quick. 177.6 minus 185 divided by 26.7 divided by the square root of 48. Yeah, that's right.
Negative 1.92.
Yeah, it's just negative, yeah.
Okay.
Let me look in the book real
If it's
quick.
negative, then we should... Oh, this is confusing. So if the z-score is negative, that doesn't make sense.
Okay, let me see. Let me see. There might be some help in the book somewhere. Here. After finding a z-score.
Hey guys, so when we do that, when we do like kind of what I was saying, it's 0.9726 basically times 2 plus another. It doesn't add up to 1 because I'm doing that right now.
Okay, so what are you doing?
So what I did is I shaded the bottom and the middle, and then I looked at the area, the number that gives you at the top, and it says 0.9726. So then I wrote that down, and then I shaded just the top part and the middle, and left the bottom part, or like the left part, unshaded, and it's the same value. And so then you just add those 2 together, and it's 1.9452.
1.9452.
So I think that might be the answer for number 4. 1.945.
Which that would mean it's over 100% chance. Which is where I'm at.
But there's a problem like that. I thought it was.
Is it in the homework?
Yeah. Oh, okay.
Random sample.
So, okay, I get it. So, what we actually do is, so it gives you, when you shade everything, like, but the right part, it gives you 0.9726. So then you take 1 minus that, and that gives you 0.0274. And then that's what it's going to be for the bottom part too, just the left part. If you leave everything shaded except the left part, so then you just add those together, and then that's your answer. Because on the homework, that was the last problem that we did together for the second part 2 on the homework.
Yeah, I remember that in the prep.
And that would be 8.
Okay, let me look at it real quick so I understand what you're saying. Okay, the probability observed is less than 8 or greater than 12. So you do...
You just shade the bottom and the top. That's the case, because the probability is 0.4 and negative 0.4, so all you're doing on that one is shading the bottom and the top.
So bottom, top?
Isn't that what...
We're losing her.
Hello?
Hello?
Can you hear me?
Yeah.
Okay. So I just did it the super long way, but yeah, I guess if you just shade the left part and the right part, it adds up to what I was trying to explain.
So
0.00549.
Okay.
Yeah. So
I don't...
0.55. I mean 0.055.
Yeah. I think that's what we were going to do in the first place, Colin, isn't it?
That is what we were going to do in the first place, but but I don't know. I mean, I don't have a better explanation as to why not to do it.
Yeah, I don't know for sure.
So I mean, we'll just have to go for it and hope for the best.
Okay,
yeah.
I'm confused on number 10.
Okay. Number 10?
I'm actually confused on number 9 too. The random sample of 5 students, the scores were that, and so when
the
you add
random
all those
sample
together,
was 60. Yeah, so it was, you add them all together, divide by 5.
and that was 160.
Yeah, that's the, and if X with a line over it means random sample, then that's what we put in first, right?
So 160 minus 150.8.
Yes.
160 minus 150.8. And
But
then
you divide it by your sample, your standard deviation, which is 8.8, divided by the square root of 5. Because we have 5 samples. That's our sample.
I don't know how to do that all in line on my calculator, so divided by 8.8 equals, I don't know how to do that.
I would do 8.8 divided by the square root of 5. And
that's 3.9.
Yeah, and I'm not sure what calculator you have, but what you can do is if you have a TI 30X IIS, what you can do is you do 9.2 divided by, then use a parentheses sign.
Okay.
And then put 8.8, then divide 8.8.
Okay.
And then hit second, get your square root of 5. And then hit 2 parentheses after you put 5 in.
And so what did you get?
2.338.
Okay, that's what I got.
Yeah.
Okay, and so that's the answer
talking about?
Yeah, that's 9.
2.23. Okay. Yep, that's good.
Okay.
That's what we had before.
So
yeah,
this
I was
is,
just confused about it. And then
yes.
10, it says the probability that 5 will have a mean score that is greater than the mean achieved by the previous problem. So what are we doing there?
So then we're going to put our z-score that we just found, and then we're going to shade above that because it's going to be a greater.
2.338. When you put 2.338, the z-score, do you always put it in the bottom one?
Yeah.
And
the
then
top
we're
one
shading.
is not the z-score. Yeah. Then we're shading just above it, so to the right. You there?
Yeah. So then we have 0.009.
Right, but when you round 9, it goes to 1, but it goes to it moves over 1 because it's a 10.
0.010.
Yeah. Yep.
Okay.
Okay, so 11. Suppose that the mean GPA of BYU Idaho students is 3.5, standard deviation is 0.7. It is well known that the distribution is left skewed, but the sample is 81 students, so that doesn't matter. So what is the shape of the sampling? It's going to be normal, approximately.
Approximately, okay.
What is the mean distribution of the sample means for all possible sample sizes of 81?
So the mean, that's the one formula we just use all the time, right?
Right.
The mean of the sample mean is the sample, which is...
should be 3.5. This is where I get confused on sample mean being different from the mean.
I think it's 81 minus 3.5.
So 81 is the sample size, though. That's
yeah.
81.
But if you remember the last one we did, Teresa, it always said that the sample mean and the mean are the same, right? That's what the book said.
Right. So we'll just
So it should be 3.5.
We only have one number.
Yeah, we only have 3.5.
3.5 is the only number we have. So we got to go 3.5.
Right. See, that's just where I get confused on the... There's no formula. It's just 3.5 because it's asking what is the mean.
Oh, okay. Never mind then. Yes, 3.5.
This is where I get really confused because... This is where I get really confused at the top because...
They're just trying to throw us off by just saying what's the mean of the distribution sample of means.
Right, but see, when we were doing 8 and 9 and all that, we were getting a sample mean by taking all of our numbers and dividing by 5. But they already gave us a mean. So that's where I'm really confused at which one goes where up there.
For number 9, it just happened to be 160, just like
Okay. But I think
150 was the median. You what?
Well, because X with a line over it doesn't equal the sample mean. It equals a random variable.
So you don't think...
Okay.
So, let's do 13. So, what is the standard deviation distribution of a random variable, the mean of 81 students who are selected?
So is this little... Because this is a random variable sample mean. This is what we've been trying to use. True?
Yeah, so what is the formula for this then?
Well, this is the one we've been trying to do, but we don't have standard deviation.
So is it...
Something. 81. So, and we have 3.5 and 0.7. Is that what numbers we're using here?
Yeah, that's the numbers we have.
3.5 and 0.7, and the sample is 81. What is the mean? Okay, so that's 5. What is the standard deviation
of a sampling?
So 0.7.
But I think it's 0.7. Is it times or divided by 81?
Divided by
the
square root of 81.
Yeah, I think that's what it is.
Yes. So it's the square root of 81.
So I think the standard deviation is, because it's the standard deviation of the sample. So 0.078 is what I got.
0.078.
Yeah.
That's what I got too.
Okay.
Number 13?
Yeah.
Wait, how did you get that? You didn't do...
We just only had to find the
standard deviation
of the random variable. So we just had to do that.
So you didn't do 0.7 times the square root of 81?
We did divided by. I'm not sure where that formula is. It's times. Where did you get that formula that it's times?
I keep saying times. I just am saying that, and I keep meaning to say divided.
Oh, okay. Okay.
So
good, because I'm like, I can't find that anywhere.
I can't find that formula anyway. That's what I get to.
So 0.078.
Yeah.
Okay.
Okay.
So you still skip number 12?
No, we got 3.5. Okay, 14. What is the probability that the... What'd you say?
I don't know why it keeps going in and out.
So the number 12, we got 3.5.
Two more. Come on, guys. Really torturous today.
Okay, so what is the probability that the mean GPA for 81 random selected BYU Idaho students will be less than 3.3? Okay, so we put 3.3.
This formula is 3.3 minus 3.5. Is that?
Yeah, correct. And then it'll be our standard deviation, which we just got, which is 0.078, or whatever that is.
Oh, yeah, because we already just barely worked that problem out, right?
Although we did round, so I don't know if we should. I think we should put it back in.
Okay. So we got that by doing the square root of 81.
Yeah.
Divided by
8. It should be 8. Oh wait, what's our standard deviation on this one?
It's 0.7.
Okay, yeah. So 3.3 minus 3.5 divided by 0.07. 7. Square root of 81, right?
Right.
So it should be, I got negative 0.03. Negative 0.032. No, that was for that's what I got for the z-score. What'd you get for your z-score?
0.0777.
Oh, we got different z-scores. Okay, so 3.3.
That's what I got. That's what I got for the bottom number.
Okay.
The square root of 81 divided by 0.7, right?
Yeah. So.
Am I behind you?
0.7 times the square root of 81, right? Correct?
Uh-huh.
What did you get
Divided
for that?
by. I got 0.7 divided by. What's the square root?
0.078. Okay, yeah. So 3.3 minus 3.5 divided by 0.7 divided by the square root of 81. So I got negative 2.571.
3.5 equals divided.
Okay, that's what I got.
Negative 2.571.
So is that the answer?
No, because that's the z-score. We want it to be less than that.
Oh.
So we want to put negative 2.571 into our probability and shade to the left of it. Which is
0.005?
Yes. Okay. Everybody good with that?
Wait, 0.005?
Yeah.
Mm-hmm.
Okay, so what is the probability that the mean GPA for 81 selected BYU students will be greater than 3.3? So now we're just going to shade to the right of it.
So,
all the way right.
Okay, come back.
Okay.
I can't get that to work. On 14, I'm shading just the left part on the left of the negative.
Yes, and your negative, it should be negative 2.571.
I can't get the other part above it to stop being shaded.
Your probability output is malfunctioning then.
Okay, so then if the bottom is shaded
then
only,
would 15 be the same answer then, if the opposite side?
It's just the opposite side, yeah. So you could do 1 minus that last number we got, but it's going to add up to 1 in the end.
So I could just do 0.005.
Yeah, that's what we got.
So I'll just use the top one because the bottom one won't do it. So.
And then this next one we got is 0.995, which makes sense because if you add them together, they equal 1. So shaded to the left and shaded to the right will be that number.
So for 15, you got 0.995?
Yeah.
Okay. Okay, and I still didn't hear you for number 12. Every time it cut out right when you said it.
It's 3.5. It's the same as the mean, we think.
Okay, sounds good.
Yeah.
So did we finish it off?
Great.
Okay.
Okay, tell me how you got 15 one more time.
You shade to the right of that z-score, that negative z-score.
So the negative 2.57, you shade everything to the right.
Yeah.
You got 995. Okay, got it. Shading is killing me. I don't know.
Yeah, it's killing me too. Our teacher needs to go over that bad.
Yeah, it's hard. I don't know. I'm not 100%
Are we ready to
about
submit?
this.
Yeah, I think we should just submit it.
Okay, ready?
We did our best.
It's not too bad.
Hey, that's not too bad.
That was pretty good.
Well,
we only got 5 wrong.
That's the only one we got wrong?
Yeah, that's the only one I got wrong.
Wait, I got 13 wrong too.
I only got 5 wrong.
I got 13 right.
Okay, well, whatever.
How did we get Okay, so what's 5?
Which of the following have a smaller standard deviation of 9 observations of randomly drawn from a population?
I guess we could determine the distribution of the sample means if we had the numbers.
So that will be, the sample mean is always going to be smaller than the population mean?
Yeah.
The following standard if 9 observations are only done. So the population, so the sample is going to be smaller.
Yeah.
The sample means will be smaller. So it's probably B. Oh, it is B.
It was
okay.
B.
Okay, yeah, that's probably right.
Yeah, that makes sense.
Because we have to divide it by the square root of the numbers, and so that's always a smaller number.
Yeah.
Okay. Well, that's
we did the rest right. Yeah.
I'm pretty impressed with that number.
Yeah, that took forever, and we got all of them right. The number ones.
Awesome.
Okay.
Nice job.
You guys need to. I'm gonna go post a video now, but you have to comment on it now. You have to reply to the post that says I attended.
Okay.
How do you do that?
So go to group collaboration. I'll just.
Okay. Go to group collaboration. We can do it there.
Yeah. So if you go to group collaboration, you're gonna see a post from me as soon as I end this video.
Okay.
That will say, "This is our group," or whatever. Here's our link. But you need to reply to that. In the bottom right corner, it'll say reply and say, "I was at this meeting."
Okay. Just on that group collaboration. That's all we have to do.
Yeah, after I post it. So I'll tell you that after. I'll end the broadcast now and I'll go post it. But that's the new thing he wants us to do.
I read that, but I wasn't quite sure, so I'm glad you did.
Yep.
Hey, that's pretty awesome. I'm pretty proud of us. So good job.
Yeah. Good job, guys.
Thanks.
See ya.
Okay, bye.